Okay, so in this video we will try to plot the amplitude modulation and the frequency modulation signal. I will not go in details about the derivation and theoretically what it is. So what I need is I need the equation for the our message signal, equation for the carrier signal, and equation for the amplitude modulated signal, and the equation for the frequency modulation signal. So these signals we will be plotting into the canvas using JavaScript. So for that already I have taken the HTML file. Inside the HTML file we'll add the JavaScript code. So let's add the script tag. Type will add I'll take the self-invoking function. Then inside the function we'll write our logic. So let's take the constant variable for the canvas. We'll create the canvas element using document.createElement, and we'll give the element name canvas. We'll set the canvas ID equals to say canvas, then canvas width. I want to plot the animation in the entire browser window, so and the width will be the windows dot inner width, and canvas dot height will be the windows dot inner height. Yeah, and the background color of the canvas I want in black color, so background equals as 000, so that will give the black color. So yeah, the when element is ready, we'll append to the body tag document.body.append child canvas. Let's take one more constant variable, that is for context, and to draw the animation. So I will get from the canvas dot get context 2D. Yeah, so we'll save. Let's see if everything is ready as of now. Yeah, we have the canvas with the black color in the background. Okay, so to draw the signal, so what I'll do, I have four signal. One is the message signal, carrier signal, amplitude modulated signal, and the frequency modulated signal. So first I'll draw the message signal that I want in the top, and what I'll do, I'll divide the canvas height by in the 4 rows. In the first rows we will draw the carrier signal, message signal. In the second row I will draw the carrier signal. In the third row I will draw the amplitude modulated signal, and then the fourth row I will draw the frequency modulated signal. So let's do that. So first I need to give the labels for the rows. So just get the function display signal label. Okay, and inside this we'll write the labels and context dot begin path, context dot fill style. I want the label color in white, so FFF, and context dot fill text. So the first label will be message signal, so this is M of t. We'll draw that one, M of t. Then the position will be the 10 pixel to the 10 pixel from here, 10 pixel, and y position will be somewhere here. I want to label M of t, then C of t, AM of t, and then FM of t. So that will be the x will be the 10. Then the height I'll take around 16. So for that let's take the font style of the text, context dot font equals, I want 16 pixel in the height, and style I want in the Arial. Okay, let's set this, context dot close path. Let's check if it is yeah, we have to call this first. So to call this I'll create another master function. Inside this we'll draw all our animation. So function draw signals. Okay, and inside this we'll call this function, and this draw signal will call at the bottom, and later on we'll put into the loop. So draw signal, we'll call this. So let's check if it is labeling here. Yeah, we have MFT here, right? So likewise I want CFT, then MFT and FMFT. So we'll go here and context dot field text, that will be C of T, then position will be 10, then location will be the canvas dot height by 4 and then plus 16. So then context dot field text will be AM of T, amplitude modulated signal of T, then 10 pixel, right? Then location will be 2 times canvas dot height by 4 plus 16 pixel. Then for context field text, we'll take FM of T, then location same 10, then this will be 3 times canvas dot height by 4 plus 16. So let's check if it is plotted correctly. Yeah, so we have the message, carrier, amplitude and frequency. We'll plot the signals here. Okay, so now we'll take this signal frequency signal, and it will have each signal will have the amplitude property and the frequency property, right? So we'll take that one. So we'll take amplitude and frequency as input, and we'll set that amplitude equal to amplitude, then this dot frequency equal to frequency. And to draw the signal, I'll use the property Okay, so let's take signal dot prototype dot so this is function prototype dot draw signal equal to function, and while drawing we'll take the time interval. So you know that to draw the signal time is variant, right? Based on the time we have the amplitude value, resulted value. So we'll take this time as an input variant and we'll draw that. So along with that, when we have the result, whatever the result we have to store in some array, right? So let's initialize the array for all the 4 signals what we have. So where message y position equals to array, then carrier y position equals to array, then amplitude modulation y position to array, then frequency modulation y position to array. Okay, so every time when we draw the signal, we'll pass the like if you're plotting for the message, then we'll pass the array. So let's take the array as a variable name here. Then one more thing, we need the offset. So when we draw the signal, so carrier signal, a message signal will be here, the carrier signal will be here. So this is the y offset, right? Y position. This offset we will pass while drawing the signal. So let's take that also as input. So y offset. Okay, let's draw that. So let's take the temporary variable called y equals to, so this dot amplitude multiply by math dot cosine of so 2 times pi. So we need pi, so let's initialize the constant variable for pi also at the top. So we have constant here, pi equals to math dot pi. Okay, so we'll use this pi here, pi times frequency. So this dot frequency then multiply by time interval what we have passed here. So once I have the value, then I will push into the array. So array dot unshift equals to y. Now for all the value of the array, let I equals to 0, I is less than array dot length h, then I plus plus will draw. So context dot begin path, context dot fill style. So message signal I want in the white color, so has FFF, and context dot arc, I'll take the points will be in the circle, so I'll draw the points here. So the location will be the I, then whatever the y offset we have taken minus what array we have inside the value what we have. Then the radius will be the small, I want at the single point, radius will be 2, then the starting angle 0, then end angle will be 2 times the pi. And yeah, so let's fill this and close the context. So it will be drawn. So when the signal is drawn, so it will move from left to right, and when all the y positions will be pushed into the array. So our array will be keep on increasing. So what we'll do when our I interval is, length is greater than the width of the canvas, then I will remove the some y value. So we don't need those value again, right? So why we need to increase the array simply. So what we'll take the if condition. If array dot length is greater than canvas dot width, we will remove that. So array dot pop, the last value what we have inserted will remove. So yeah, this is done. This is for the plotting the signal. So let's create the message signal using this function. Give name signal function. Okay, let's create the message signal function. Okay, function message signal, and so this dot message signal equal to new signal, and it will take the amplitude. So say I want amplitude 30 and frequency around 20. So yeah, it will initialize, and let's draw the message signal also. Message signal dot prototype dot draw message signal equal to function. So it will take the time interval, and this will have this dot message signal dot draw signal from the inherited function from this one from the function signal function. We'll get this function. So now we want the position. So the time interval will be t, then we have the another parameter called array. So that will, since it is message signal, so we'll pass the message y position array, then the offset. So for the message signal, the offset will be total whatever the quarter height we are having. So it will be like canvas height divided by 4. Then from this height I want the center location, so again we'll subtract the half of that. So let's do that. So canvas dot height by 4, and from this result we'll divide canvas dot height by 4 divided by 2, right? So it will give me that. So it will draw that. So let's create the object of this message signal at the top. So where message equal to new message signal. Okay, and inside the draw function we'll call that. So draw message signal, and we want time interval. So when we are passing the time interval, we'll pass here also inside the function. And so let's initialize this time interval at the top. So we are having the where here. So t equals to 0, and we will keep on increasing this t in the loop functions to see the graph is moving. So let's create the loop function at the bottom. Function loop, and inside this function we will increment the t value, and it will be, we know that pi will give the 180 degrees, so when we divide the by 180, then we will get the value for 1 degree, and for all the 1 degree I want the small value, that is will divide by 100, so that for each degree I want I want the some other 100 coordinates to smoothly draw the curve. So that is why I'll divide by 100, and this will pass inside this draw function. So we'll call this inside the loop function, and we'll pass this t here, and let's call the loop function once. And also to animate, we'll add the request animation frame. Loop callback function will be the loop function. Yeah, let's save and check if it is plotting. Fine. Yeah, so but we didn't clear the canvas, so that is why we are having this extra white spaces. So we'll clear that canvas. So context dot clear at 0, 0, canvas dot width, canvas dot height. Yeah, so now if you see, we are having the message signal with the amplitude 30 pixel and the frequency around 20. So this is plotted. Now let's create the function for the carrier signal. Function carrier signal. We'll take this dot carrier signal equals to new signal, and the amplitude and frequency we have to decide. So let's pass the amplitude 30, and frequency will take higher than the message signal. Let's take the frequency around to 10 times the message signal. So message signal we are having 20, so 20 times 10 means 200 frequency will take. Let's store this carrier signal dot prototype dot draw carrier signal equal to function. Yeah, so same here, we will pass the time interval. Okay, and let's store this. So this dot carrier signal dot draw signal, and it is expecting the parameter t, then array, since it is our carrier, so we'll pass the carrier y position array, and then offset. So the location of the carrier signal is in y direction. It is the Windows height by 4 plus again height by 4, then minus, so we'll take 2 times of height by 4, then again height by 4 by 2, we'll subtract from that. So let's do that. So it will be 2 times canvas dot height by 4, then minus canvas dot height by 4, then divided by 2. So this will be the y offset for the carrier signal. Let's get the object of this also at the top, where carrier equals to new carrier signal, and we'll call inside the draw function draw carrier signal, and it is expecting the time intervals. We'll pass the t. Let's check if it is drawing now. Yeah, so we are having the message signal, and this is high frequency carrier signal. Okay, so these two we have drawn. Let's draw the amplitude modulated signal. The equation for this amplitude modulation is, you can see, we are this is one factor, and this is the amplitude for the this cosine function. So we'll draw this signal now. So let's create this separate function for this. Below here we'll take amplitude modulated, so let's take the function amplitude modulation, and it will take the time interval t, then let's take the time interval t as of now. We'll see if we need any other parameters. So first of all, what I need the value of this value. I'll calculate and put into the temp, then we'll add with the amplitude of the message signal. So yeah, while drawing the signal we need the message signal and the carrier signal as a parameter, so we'll pass that one here. So message and then carrier. Okay, yeah, so we'll pass that. So let's take the temp message value, and this is nothing but the value of this component. So we have the amplitude of the message signal, right? So message signal, we have message signal dot amplitude multiply by math dot cosine of it is 2 pi fmt, right? So 2 times pi times message what we have taken parameter dot frequency times time interval. So we'll take the another parameter as t also. So yeah, this will give the time value. Let's then we'll sum it and we'll add with the amplitude of the carrier signal, then we'll multiply with this cosine function. So let's take y equals we will take the carrier parameter what we have taken, the amplitude of this amplitude, then plus the temp message value what we just now we got, then multiply by math dot cosine of 2 times pi times the frequency is the carrier signal frequency. So carrier dot frequency, then multiply by time interval. So this will give me the final y. So once I have this, I need to store in the array. So let's take the another parameter called array. This we can say am array. Okay, inside this we'll say we'll set the value. So am array dot unshift, we'll put the y value. Okay, and for all the value of this array, I equals to 0, I less than am array dot length, and then I plus plus a context dot begin path, context dot fill style. So I want in different colors. Say already I have taken the color picker here, so I want in yellow color, say. So I'll put this value, the color of the amplitude modulation. So this is the color for the amplitude modulation signal. So then context dot arc, we will draw the point. So the location will be the I, then the offset also we have to pass. See, the offset will be y offset, and this offset will set here, and from this we'll subtract whatever the am array we are having in the value of I index, then the radius will be around 2 and the starting angle 0, end angle will be 2 pi. Yeah, so then context dot fill, context dot close path, and same way we'll check the if array am array dot length is greater than canvas dot width, then we'll remove that am array dot pop. Okay, so it is done. So let's take the call this function inside the draw function we are having at the top here, and we need to pass the value. So we'll pass the message signal, message, then carrier, then we will pass the time interval, then it will be t, then we will pass the array, so that will be am y array by position, then we want the offset. So the offset of this one is if you see here, so 3 times the canvas dot height by 4, right, and then we'll subtract, so it will be 3 times canvas dot height by 4, then whatever result we have from that will subtract canvas dot height by 4 and result divided by 2. So this will give the y position. Yeah, so and then anything, any other parameter we have. Yeah, so yeah, we gave all the parameter. Now let's check if it is towing. It's not doing. Let's check if we have any error. Everything's fine. We may have some non-index. Let's debug and check. So what we'll do, we'll go to the amplitude modulated signal and let's check all the parameters are coming correctly. Yeah, so here we are having frequency as undefined, right? So we'll pass that. Amplitude we got undefined. So while passing this message and carrier, the signal here, we'll pass this message signal. So yeah, message signal dot message signal will pass, right? That one will pass because inside this we'll have the array, and the carrier dot carrier signal, right? So that signal will have the frequency and amplitude, isn't it? Let's check now. We'll run this and we'll check if we have all the value correctly coming. Yeah, so we can see, yeah, all the values are coming correctly now, so we can remove the debug point. Yeah, so this is our amplitude modulated signal. So simply if you see the meaning of this amplitude modulation, the carrier signal amplitude is changing based on the amplitude of the message signal. So when the amplitude is high, we have the high modulated amplitude. When the amplitude is less, then it is less modulated. So this is the amplitude modulated signal. Now let's draw the frequency modulated signal. The equation is this one, and if when you see your message signal with cosine, this factor is beta times the sine. So this beta is nothing but the modulation index, and this is the component for that. So what I'll do, I'll just take the constant value for beta. I will not go for the derivation. So let's take the constant beta value. At the top we'll take the constant beta equal to, say, 5 I want, the modulation index, and it could be greater than 1 and less than 1. So when so they have it has the meaning, when it is greater than 1 it means it is wideband frequency modulation, when it is less than 1 it is narrowband frequency modulation. So I'm taking the positive 5. Let's do the plotting of the frequency modulation signal. So here in the below of amplitude modulation, I'll take the function frequency modulation function frequency modulation, and it will have the same parameter as we had for this. So I'll copy the parameter thing, and I'll copy this component also, this from here, insert this, and yeah, so here we have to calculate some value, some temp values, and these are this one. So first I'll calculate this component value. So beta times the sine function of 2 pi fmt, right? So let's take temp message value we call, because it is a product of message signal, basically message frequency signal. So message value equal to beta times math dot it is sine function, sine, then 2 times pi times the frequency of message signal. So message signal message dot frequency times the time. So this is the temp value. We'll add this temp value with the frequency factor of cosine function. So let's take let y equal to carrier, no, this is different. It will be the amplitude of the carrier signal. Yeah, that is fine. Amplitude of the carrier signal, then multiply by the function cosine function, then 2 times frequency of the carrier signal, that is fine, frequency of the carrier signal. Then we'll add the plus the temp value what we got. Yeah, so this y position already we have shift, and yeah, so everything is fine. I think we got all the value. Let's call this function inside the draw function. See, frequency modulation, and we want the same thing. Here these two will be the same parameter till time interval, and then after time I want the frequency modulation y position, right? In that array will push, and that this time the location of FM signal will be the total height minus the height by 4 divided by 2, right? Half of that. So we have the canvas dot height minus then canvas dot height by 4 then divided by 2. So this is the location of frequency modulation. So let's check. So if it is plotting successfully. Yeah, so we can see when we have the amplitude less, then the frequency of the modulated signal is less. When amplitude is high, the frequency of modulated signal is high. So this was the plot of the amplitude and frequency modulated signal. Thank you for watching this video.